Question 2. The diagram shows 7 shapes A, B, C, D, E, F and G on a centimeter square grid. So every one of these lines is 1 centimeter long. Part A. What is the mathematical shape for, or the mathematical name for shape E? That's this shape here. Well, it is a quadrilateral, but it is a special type of quadrilateral where we have a single pair of parallel lines and nothing else of significance, no lines of symmetry, no equal lengths or anything like that. So shape E is a trapezium. Part B. Write down the letters of the 2 shapes which are congruent. Congruent is fancy chat for equal in terms of shapes. So we're looking for 2 shapes that are equal. Now, these shapes are equal, but they can be rotated, or they can be a different, look in a different position. So if we look closely, D and F are both right angle triangles where one of, that was a rubbish line, one of the lengths is 3 centimeters and one length is 2 centimeters, and then we have the diagonal length connecting them. So D and F are our congruent or equal or identical shapes. Part C. Mark an obtuse angle on one of these shapes. Label your angle X. Well, pick an angle that is bigger than 90 degrees but less than 180. Any of the following that I'm highlighting here in orange would do. Are there any others? No. Nope. There we go. I don't think there's any others that I can see. So any of those angles in orange I've marked there would be acceptable for an obtuse angle. D. How many lines of symmetry has shape B? Well, shape B is a square, and a square has 4 lines of symmetry. One running vertical, if you tilt your head so you look at this, one running vertically, one running horizontally, and then 2 running diagonal. Now my picture's not going to win any awards here, but you have 4 lines of symmetry, like so. Part E. Work out the area of shape C. No, need a new colour. Shape C. So area of shape C means that we care about the amount of space that's inside this shape here. There's more than one way of doing this. You can do it by counting squares, and if you're careful with how you count these in terms of the whole squares inside, you end up with 6 whole squares inside that I'm showing here, and then you've kind of got bits of squares in terms of the diagonal bits in here. They end up equaling 4, and then you add it to 6 and you get 10. That would be a perfectly acceptable way of answering this question. However, there's a better way, a quicker way. C is a special quadrilateral known as a parallelogram. There's 2 pairs of equal sides and they're parallel. The formula for the area of a parallelogram is base times height. So our base of this parallelogram is what I'm highlighting there, 5 centimeters wide, and the height of this parallelogram, which must run perpendicular to the base, is 2 centimeters. I could also draw it here like I've done there. So effectively we have 5 times 2, which is 10, which matches the other answer that I gave you before, giving us our final answer 10. I should write 4 in there for the symmetry as well.